All right, so we're going to start our chapter on series. First off, let's start with something that you are familiar with. 7 divided by 5. What does that mean? Other than 7 divided by 5.
She just jumped up and down.
But y'all are thinking calculus is fun right now, so that's my goal. All right, so what does 7 with an exclamation mark mean? Okay, right, 7 times 6 times 5 times 4 times 3 times 2 times 1. All right, the fact that I'm trying to simplify this, though, let's think of 7 factorial as 7 times 6 times, and then instead of 5, 4, 3, 2, 1, 5 factorial. All right, so now the 5 factorials cancel, and someone had said a few minutes ago that the answer was 42. All right, now let's do the same thing with when we have variables. Which one is bigger, the numerator or the denominator? N factorial or n plus 2 factorial? It's going to be n plus 2 factorial, right? So n plus 2 factorial would be n plus 2 times what? Times n plus 1 times n minus 1 times n minus 2, etc. But I'm going to stop with n factorial because I have an n factorial on top. So they'll cancel out. So this will simplify to 1 over n plus 2 times n plus 1. All right, a sequence is an ordered collection of numbers, and its domain is the set of positive integers, like 1, 2, 3, 4. So any collection of, an ordered collection of numbers. So any kind of numbers that has some sort of pattern to it. For example, a sub n equals 1 over n. Let's write out this pattern of numbers. So the domain, or what I'm plugging in for n, are my positive whole numbers. So I'm going to start with n equals 1. So 1 over 1 is 1. And then n equals 2 would give me 1/2. And n equals 3 is 1/3. And then 1/4, etc. Okay, write out the first, say, 3 terms for number 2, starting with n equals 1. If n equals 1, 5/3. 20 over 6. I don't really care about reducing. 45 over 11. Is that right? Okay. Etc. All right. A sub n is considered to converge. And what does converge mean? Yeah, come together to a point, approach a specific point, or in this case, a specific number. So a sub n will converge to a specific number if the limit as n approaches infinity of a sub n equals some number L. And it's said to diverge if that limit equals infinity. All right, so let's find the limit of these two. So the limit as n approaches infinity of 1 over n equals what? 0, right. 1 divided by infinity is 0. What that means in terms of the sequence is that those terms way, 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 way out when n is really, really big are approaching 0. So like my next few terms would be 1/5, 1/6, 1/7, etc. But as n gets bigger and bigger and bigger, those terms are approaching 0. So if I were to continue to list out that sequence forever and ever and ever and ever, as n approaches infinity, those terms are approaching 0. All right, number 2. What's the limit as n approaches infinity of 5n squared over n squared plus 2? It's 5. Technically, you get infinity over infinity, which would require us to use L'Hopital's rule. And we could use L'Hopital's rule a couple of times. However, that also fits those horizontal asymptote rules because the degree of the top is the same as the degree of the bottom. So therefore, the limit is the ratio of leading coefficients. All right, so we could plug more numbers in for n and get these, but eventually these terms are going to be approaching 5. So that's what we mean by the limit of that nth term. All right, a series is then a sum of a sequence. So all we do is we take those numbers of that sequence and we add them up together. So instead of commas between all of the terms, we have pluses. All right, this notation right here is called your sigma notation, or the summation notation. And it means that you're plugging in a 1 for n, and then a 2, and then a 3, and then a 4, and you're adding all of those up until you get to n equals infinity. So if that sum becomes infinity, the series is said to diverge because it's not approaching a specific number. But if that sum stays finite, then the series is considered to converge. And that's a very strange concept to think that you're adding up an infinite number of terms, but when you add it up, you get a finite number, and that does happen. But it's kind of a strange thing to think about. So the best example that I have for that is something like 3/10 plus 3/100 plus 3/1000 plus 3/10,000. Would you agree that there's some sort of pattern to those numbers right there? All right, well, another way to think of this is 0.3 plus 0.03 plus 0.003 plus 0.0003. And if I keep adding that pattern up forever and ever and ever, what does that add up to be? 0.3 repeating, otherwise known as 1/3. So I took an infinite number of things and added them together forever and ever and ever, but got 1/3 when I did it. All right, so the rest of this chapter is devoted to, does the series converge? And if so, to what value? What is the sum of that series? All right, so if I have an infinite series, and I know that it's an infinite series because of the summation notation makes it a series that I'm adding, and then that infinity up there makes it infinite. So I'm adding up an infinite number of terms. We can talk about a partial sum, or the nth partial sum. So S sub n represents the sum of the first n terms. Or, for example, S sub 4 equals the sum of the first 4 terms. S sub 8 would be the sum of the first 8 terms. All right, so one way to determine whether or not a series converges or diverges is to think about whether the partial sums is getting bigger or not. So this one actually diverges because the sequence of partial sums is getting bigger. All right, what we mean by that is the first partial sum is just the first term, is 2. Well, S2 is the second partial sum, and that means that I add the first 2 terms together. So 2 plus 4 is 6. S sub 3 means I'm adding the first 3 terms, 2 plus 4 plus 6, which equals 12, etc. So every time I add on another term, what's happening to the sum? It's getting bigger and bigger and bigger. So that sum will never actually approach one specific number. It's going to approach infinity. So that's why it's said to diverge. Okay, what do you think 2 plus 2 plus 2 plus 2 plus 2 forever and ever? Is that going to converge or diverge? That one will also diverge, and kind of for the same reason, because the first sum is 2. The second one is 2 plus 2, which is 4. The third one is 2 plus 2 plus 2, which is 6. So it's fairly common sense that that one diverges. Okay, so in order to converge, what do you think the terms need to be doing? Right, the terms need to be getting smaller. All right, so here's a series where the terms are getting smaller. So let's look at the partial sums. So the first term is 2. The sum of the first 2 numbers would be 2 plus 1.5, which would be 3.5. The sum of the first 3 terms would be 2 plus 1.5 plus 1 1/3, which I believe is 4 5/6. Okay, so the sum of the first 4 terms, what's going to happen is I keep adding terms for my sums. Are my partial sums getting bigger or smaller? Bigger. They're still getting bigger. So I'm still adding more and more and more. So it's still going to diverge. All right, another way to think about this, and I think this is the easier way to think about this, is let's take the limit as n approaches infinity of a sub n. So the limit of my nth term. Before I do that, let's write out a few more terms. What do you think the next term would be? 1 1/5. And then 1 1/6. And 1 1/7. So as n approaches infinity, or my number of terms approaches infinity, what do you think that nth term is going to approach? The next one would be 1 1/8, 1 1/9, 1 1/10. It's going to approach 1, right? The nth term is going to approach 1. So when I go way, way, way far out with a large number of n, it's like I'm going to be adding 1 plus 1 plus 1 plus 1 plus 1, or something really close to 1 plus 1 plus 1. All right, so that's another way to think about it diverging, because if I'm always adding 1, I'm never going to approach a specific number. All right, so the terms getting smaller is not sufficient. The terms must be getting smaller and also be less than, what do you think, 1. Okay, so let's think about this right here. This is just kind of an alternate way to write that sum. This n over 2n minus 1 is considered your nth term. So what's the limit as n approaches infinity of n over 2n minus 1? Right, it's 1/2. The ratio of leading coefficients would be 1/2. So I can take this sum and I can plug in some numbers for n, but eventually it's going to be like I'm adding a half plus a half plus a half plus a half. So will that converge or diverge? Okay, it's still going to diverge. So what do you think that nth term needs to approach in order to converge? 0. And even that is not a guarantee. To stand a chance of converging, the terms have to approach 0, or the limit as n approaches infinity of a sub n has to equal 0. Just because they do approach 0 doesn't mean that it will converge, but to stand a chance of converging, that's what has to happen. And this brings up what's called the nth term test for divergence. I want you to put a huge star next to this, because we will use it every single day, and this is the first thing you're always going to want to check. And I underlined divergence here. You might want to put a huge, you might try and highlight it or make that stand out more, because this test only tests for divergence. It doesn't tell you whether a series converges. So what it says is that the limit, if the limit is n approaches infinity of a sub n does not equal 0, then we for sure know that the series diverges. Because if that nth term approaches, say, 2, it's like adding 2 forever and ever and ever and ever again. All right, the problem is you cannot use this to argue for convergence. So it only works to tell you, okay, I know it diverges. Determine if the series is divergent. Notice it doesn't say, does it converge or does it diverge? I just want to know, is it divergent? So to determine if it's divergent, I'm going to take the limit as n approaches infinity of my nth term. And that formula in the summation represents that nth term. All right, so what does that limit equal? 1/3. And the nth term test for divergence tells us that as long as that limit does not equal 0, the series diverges. So I'm done. And that makes sense, because that means that those terms, when n is really, really, really big, are approaching 0. So it's like adding up 1/3 plus 1/3 plus 1/3 plus 1/3 forever and ever and ever. All right, number 2. What's the limit as n approaches infinity of 2 to the n? Infinity. Does that equal 0? Nope. So this one diverges too. Okay, we haven't done much with taking limits using factorials, or n. The excited n. What does your gut instinct tell you that this limit is? 1/9, right? Okay, it's the same concept of the same degree on top as it is on bottom. You've got a factorial on top and a factorial on the bottom, so those are kind of the same thing. So that ratio of leading coefficients is 1/9. All right, so does the series converge or diverge? Diverges. Or I guess I shouldn't say does it converge or diverge, I just need to say does it diverge? And the answer is yes.